Alright, so this will be our last video in Unit 2 over angle of elevation and angles of depression. Okay? So this is kind of tying it all in, putting it into some real-world perspective problems. Alright, so the first thing we need to talk about is what is the angle of elevation, what is the angle of depression, and what makes them different. So in this picture right here, we have like a air traffic controlling tower, and here's the airplane. From the tower, looking up at the plane, okay, so this would be your horizontal line of vision. When you look up, that is the angle of elevation. From the plane's perspective, from its horizontal viewing, if it looks down to the tower, it's going to be the angle of depression. Now what we can actually say here is that these two dashed lines are horizontal lines. And we know that horizontal lines have a slope of 0. Since they have the same slope, they're parallel. Therefore, the angle of elevation and the angle of depression for this picture are going to be exactly the same. Okay? So that's going to be important in our future problems. Alright, so an air traffic controller sights a plane at an angle of elevation of 41 degrees. The pilot reports that the plane's altitude is 4,000 feet high. What is the horizontal distance between the plane and the airport, rounding to the nearest foot? Okay, so I'm going to delete this. Delete. Alright, so here's the picture. Here's the air traffic controller. And he is looking up at an angle of 41 degrees. So 41 degrees is his angle of elevation. Okay? It is our job to find out how far away the plane is. Okay? That's important when we're trying to figure out what plane should land at what time. Okay? So let's go ahead and do some math. From the angle of A, I have the opposite and the adjacent side. The hypotenuse is not given to us, nor are we looking for it, so we're not going to use the hypotenuse. So we are going to use tangent here, and we know that tangent of theta is opposite over adjacent. So the tangent of my angle, 41, is equal to the opposite, which is 4,000 feet, over x. So when x is up high, you multiply. When x is down low, you divide them, you know? So x equals 4,000 divided by the tangent of 41. This becomes, at this point, something that we type into our calculator. And double check, we are rounding to the nearest foot. So what I get is x equals 4,601 feet. That is how far the plane is away from the air traffic control tower. Alright, so here we have a tower. I am standing 400 feet away from this tower, and I am looking up at an angle of elevation of 33 degrees. This would be one of those cases where you have a clinometer, and your kilometer measures this degrees, and you know you're 400 feet away, so how tall is the tower? So we have from angle 33, this is the opposite side, and this is the adjacent. So tangent of 33 is equal to the opposite over adjacent. When x is up high, we multiply. So 400 times the tangent of 33 is equal to x. So x would be equal to 260 feet. So you are farther away. If that tower were to fall over on top of you, you are standing far enough away that if that tower fell, you would not be anywhere near it. Because the tower is only 260 feet tall and you are 400 feet away. Alright, so what about angle of depression? Okay, a forest ranger is in a 90-foot observation tower and he sees a fire. The angle of depression of the fire is 7 degrees. So as he looks straight ahead and looks down 7 degrees, he can see the fire. How far is it from the tower to the fire? Is this something that he can, just quickly jog to, or is he got to, get in a four-wheeler and get to that? What does he got to do? How far away is it? So here's my picture. Okay, here is the little tower that he's in. So it's kind of like, if you've ever been hunting, that's kind of like, you would be up in a tree, but he's got his own building. So this is where he's at, and he's looking down and he says, oh no, there's a fire. So let's draw fire, yay. Go get the fire out. Smokey doesn't want fires anymore, so get it out. So, how far away is it? Well, the tower is 90 feet. Now, if this is 7 degrees, this angle here must also be 7 degrees. The ground, degrees, not 70, there we go. The ground and the horizontal viewing are both parallel to each other. So, I can look at this triangle here and say 7 degrees, opposite is 90, and I'm looking for my adjacent, how far I am. So, the tangent of 7 degrees is equal to 90 over adjacent, so my distance. So, if x is up high, we multiply, but x is down low, so we divide them. X equals 90 over the tangent of 7. Oh, that was weird. Just went changed from a green marker to a black marker. Alright, so type this in my calculator. It says round to the nearest foot. So we're looking at 733 feet away. Okay? So just remember that a mile is like 5,280 feet. So he's well under a mile. If he needed to, he could jog to it. He could, run a hose to it, maybe, if he had a long enough hose, whatever, okay? However, probably in his best interest, he could hop on a little golf cart and go to it, okay? Alright, so from the top of a tower, the angle of depression to a stake on the ground is 55 degrees. So the first thing I noticed is that I said angle of depression. So I need to get a shape. Let's do a triangle. And then the angle of depression, so I'm going to create a line, the normal horizontal viewing line. And then I look down at an angle of 55 degrees. So the stake on the ground is here, something that's dug into the ground. And it says we're on a tower. So let's draw a wonderful tower. Maybe it's like one of those water towers, So we're standing on the top of this. Okay, and I want to know, let's see, it's 80 feet here. I want to know how far the stake is away. So what is this? Alright, now this angle and this angle are both 55 degrees. Alternate interior angles because these two lines are parallel. I'm given the opposite side and I'm looking for adjacent, so that's going to be tangent again. So 80 over x. When x is up high, you multiply. When x is down low, you divide them, So it'll be 80 divided by the tangent of 55. So x equals 56 feet. Alright, in this next problem, I'm going to want you to pause the video and try it. This is a lighthouse. It's 208 feet tall. Okay, maybe I read that somewhere in a museum or whatever. Maybe it was inside the building. There's a buoy out there, way out in the ocean. It's one of those little bobbers that lets people know, hey, the water's shallow here, don't bring your boat here. So, from that buoy, looking up to the top of the lighthouse, it's 40 degrees. That's my angle of elevation. Can you find how far away I am from the lighthouse? So I'm about to begin working the problem. If you need more time, pause the video here. Okay, here is 40 degrees. I need to label the sides, hypotenuse, opposite, and adjacent. I'm not looking for the hypotenuse. I'm not given the hypotenuse. It has no relevance in this problem. So I'm going to use tangent because tangent deals with opposite and adjacent. So the tangent of 40 degrees is equal to opposite over adjacent. So when x is up high, you multiply, so that would be 208 over the tangent of 40. So the distance from the tower is going to be 248 feet. Alright, so that brings us to the end of this lesson and to the end of Unit 2. I will see you guys later.